Next up, for the last lecture, we will have Vanja talk about WinDbg full of tricks.
Well, somebody needs to have the last lecture, I'm afraid. This is it for this year. I really had a great time at BalCCon, and I hope I have to congratulate everybody of you who survived these 3 days successfully, more or less. So give yourself a round of applause. Well done. And a word of warning that, you know, if you spend a long time in the security industry, hacking, whatever, you end up with gray beard or like a little bit less hair. So for all the young people, that's a warning. You know, it looks fun at the beginning, but you know, it takes its toll. Anyway, my name is Vanja. I work for Talos, which is like a Cisco threat intelligence group. We try to collect interesting information about various types of attacks. We are more on the defensive side. We have some guys in vulnerability research as well. Some of the people from Novi Sad actually working for our group. And yeah, I think I'm ready to share my kind of trip of what WinDbg, or some people call it WinDbg, some people call it WinDbg. So pick your favorite name. So I don't consider myself to be like really an expert of WinDbg, but I don't think that there are a huge number of WinDbg experts around. Like, how many people are using WinDbg regularly? How many people are using it for user mode stuff? How many people for kernel? Not that many. Okay. So I think it really as a tool. When I started using it, I realized that it's not very user-friendly. So I decided that I want to document my kind of trip as I kind of learned it over the period of quite a few years. I was coming back to it and going away. For certain things, you need to have it for definitely for kernel mode, Windows analysis. It's the tool. But then I was pleasantly surprised about half a year ago when I tried to find out when I realized that there are some new features that make WinDbg very useful for not just kernel mode analysis, but user mode analysis, and make it almost as easy to use as the tools that we regularly use, like, I don't know, OLEDBG or X64DBG, IDA and things like that. So I decided to give it a little bit of an intro for people who are not that well aware about what WinDbg is, and then give you, like, let's say, a few malware analysis tips, though it's, you know, very, very difficult to say. You might already know it. So, but I discovered some things. Okay, so what is it? Well, it's a graphical user interface which is built on top of the Windows debugging engine. There are more than one debugger built within Windows. There is NTSD, which stands for NT System Debugger, and CSD, Command Line System Debugger. KD, they're all command line debuggers. And then one thing that kind of puts together everything is this not very user-friendly interface of WinDbg. When you open it, you really, that doesn't give you much clue about what you're supposed to be doing. So you need to, you know, work through few steps in order to set up it properly. In the way you install it, you either install the Windows driver kit, or you can get a SDK for Windows and then choose partially install only Windows debugging tools. And there's like the recent addition of the latest version. Microsoft call it WinDbg Next or WinDbg Preview, which is the kind of tool that I'll kind of have running in a virtual machine separately as well. So perhaps we'll have time to see some of the things that it can do, and it brings quite a big improvement for the user experience for debugging on Windows using WinDbg. So what you need to know, the setup I like, usually you have something that's called debugging host, or debugger, and debugging target, or debuggee, so two things. Generally, you have two machines because when you debug the kernel code, when you break into the kernel on Windows, then the machine that you're debugging kind of stops, nothing can happen, but you have the machine that's controlling, so you have several ways of connecting. Typically, WinDbg started as a serial connection. And even if you set it up with, let's say, one virtual machine host and a virtual machine going through the name pipe, it's still very slow, and it can't achieve big speeds that you actually need to properly debug. So there are some other protocols like FireWire. There are not that many FireWire cards, but you can obviously get machines with FireWire. There's USB 2 and 3, which gives you good speed already, but I actually prefer the network driver, which allows you to set up like a virtual Ethernet connection between, my setup is two virtual machines, one which is the debugger and the other one that's debuggee, and generally over the Ethernet connection the speeds are more than acceptable. Here's the setup I have, the two virtual machines. One other option for speeding up that existed was called is a driver called Virtual KD, so virtual kernel driver, kernel debugger, that allows you to achieve much better speed, even if you have this sort of, let's say, almost like a serial connection between the two systems. So this is how you set up Windows to debug over network. You know your debugger's IPv4 address, choose any TCP/IP port, and then set up the debuggee, so the machines you want to debug, with disabling the integrity checks and allowing the test signing, which allows you to load some of the invalid certificate, driver signed with invalid certificates, or driver that are not necessarily signed. Then you enable the debugging on that machine. And then the final thing, you have to enable the debugging settings that says that your connection between the client or the debuggee and the server, the debugger, will go over the Ethernet, and you need to know host IP address, choose any port, and then you can, the key is used for encryption. If you really do it over the network, then you need to have some kind of security in that protocol. And so if you leave that key empty, that the key is automatically generated. Then once when you have the key, you go back to the machine, you start with WinDbg with a K, command line option, and you just have some configuration. You can do it from the GUI as well as such. Then you reboot the machine you want to debug, and once when it's online, you get the connection in. So that's more or less it, or anything you need to be able to debug between like the kernel on Windows. And the interesting thing perhaps it's worth noticing is that if you want to use this Ethernet protocol, the Ethernet transport, your debuggee needs to be at least Windows 8.1 or later. So if you use earlier version, that won't necessarily work. You can also have set up your own workspaces and save them. They get saved in the registry. In this HKCU software, Microsoft WinDbg Workspaces. This is one beautiful color scheme that I set up, so you can see how it can be set up. But there are some people who are much more serious about how they like their WinDbg or debugging environment to look like. So here we have Zach Burlingham, who actually, I've included the links if you're interested. You can download the workspaces that make WinDbg in its classical user interface, which is still installed when you install it from SDK or Windows driver kit. So it looks better. You have your own command line tool. I'm sorry, it's not that visible here, but you have your registers, you have your memory, you have your disassembly windows, so you have all the windows that you generally need when you seriously debug something. There is also another interesting command called command tree, and there's a guy who on GitHub created this WinDbg tree that you could put into your debugger. So a new window appears that's essentially just clickable, and if you install some additional extensions to WinDbg, it basically allows you to not having to remember all of the command lines for various investigation. He really neatly classified all the possible commands that you can then go click through, and they appear as proper command in command line, and then you slowly start learning, because the learning curve in WinDbg is generally pretty steep. Surprise, surprise, this is how WinDbg preview looks like. It looks very much like any Microsoft's modern debugging environment. So you have all the buttons, and it's interesting when you look at the defrag tools. It's called Microsoft's video series with some of the Microsoft guys, and I'm always like it's super fun when you see these, I don't know, pretty experienced programmers, and when they go through the tool, and when every time they need to step or trace a code, they click, and go, come on guys, you need two commands, T, P, P, like it's so much easier, but they prefer their user interfaces, and who am I to blame them for that? One of the most important things, and one of the, if you don't do this step, which is basically define the symbol path that makes the WinDbg download the operating system symbols, which, like, the operating system symbols is basically just a mapping between the memory location and the name of the variable or a name of the function. So you have dynamic library, so you have Windows kernel, and then somehow the symbols obviously know how to map a memory location to the symbol name. So you can basically unassemble any of the function that you know the name, and without that it's really not worth even using WinDbg. So essential step, and sometimes it takes some time to set up, but it's so basic commands. Before being a proper, let's say, malware researcher, you know that everything you do, you will forget. So the good thing is that you can actually open a log file. So when you open a log file, everything you type on the command line will be saved into the log file. You set a verbose mode, and then you get so much information that you can always come back to your analysis once when after a day or 3 months when you forget everything. The great thing is that there's also it's very well documented in WinDbg. It has a help file which you call with HH, and it's like a traditional help file all format, CHM format, but it really has a lot of documentation, though it takes through. So I kind of try to remove all this hard work, all the work you have to go through, and it takes a lot of time to actually come back to see which commands in the end are useful for analysis. WinDbg has some registers. You can have the processor registers, like the general purpose registers and multimedia registers and so on. But it also allows you to have some pseudo registers, which are equally valid over all the platforms, because Microsoft also had Itanium platforms. It will likely have some ARM as well. So, for example, you have some pseudo registers. They always starts with $. So the CSP will be current stack pointer, IP would be instruction pointer, RA would be return address, return registers, then you have process environment block, thread environment block. Those are all depending on the context where you are. For example, proc it shows you the kernel process, kernel process structure if you're in kernel mode, but if you're in a user mode, then the PEB is potentially a better structure to look for some information about the process. And then the operator image entry, which basically shows you the entry point of an image. So, I don't know. Those are the kind of basic thing. It allows you to have temporary registers, T0 to T9, and also allows you in the latest versions to have your own pseudo-register of pseudo-register names. On the top we have the difference between R. So okay, I guess we can go and have a look if it. Okay, so if I just say R, I'll get all the register, all the general purpose register displayed. This is in 32-bit environment, but the thing is that is RM, the next command, allows you to set the mask. So if you want to look at floating point registers or multimedia registers, then you can set a mask so all of the registers are displayed for you as well as you go on through the debugging process. Exploration commands, some of the basic things like X gives you all the symbols. So I don't know, we can perhaps have a look as well. X, let's say kernel base create. So this will give me all the kernel base APIs that start with create. And then their own address. So I can copy and paste the address of any function, like create mutex, for example, and then choose to disassemble that using the U command. And you can also disassemble more. You can disassemble, I don't know, 16 instructions. Well, no, I want to have L16. Yeah. So this is the basic thing, how you kind of interact with the debugger as you're going through, and you're probably aware of how they're doing it. Blah blah. No. Okay, so this is the X, so display the symbol. DT is display type. So I mentioned that you can download all the symbols. So the symbols are not just location versus memory versus the name, memory location versus the name, but it's also the data types, because like Windows has, like any operating system, notorious numbers of various structures that exist in memory during the run of the operating system. So it's almost very unlikely that everybody knows all the fields of some of the structures. So a typical example is the one I always use is the eProcess structure. So you can go DT, you know that it's in NT, and then you go eProcess. So it then shows you all the fields in this structure. So you can see there are so many fields. And this eProcess structure describes, it's basically like an object that is a memory representation of a process running in memory. It has its own threads and things like that. So it starts with another structure called kprocess. Yeah, you see, you get the point. There are too many fields to know. But the DT commands, if you know the structure name, gives you at least the idea of like what fields are available in which structure. You can also follow this DT command with the name of the structure and with an address. So you actually apply that structure to the real object in memory, so you can see various things in a real environment. So for a particular process, you can see all the modules, you can see whether it's being debugged or not, and things like that. Okay, so the next commands like display byte, display word, display double word, display quad word, and so on. Display pointer. So if you have a pointer in memory, the pointer will actually display pointer will dereference it and show where this pointer is pointing to. Then you have K. K is largely deals with a stack. So you can see the stack arguments to the functions. There are some other useful commands such as ln. So if you don't know where where you're somewhere in memory and suddenly you have no idea where you are, but you have the memory location. So we can have a look, and we had a function before that we disassembled, and we have the memory address. So if I just press ln, it will tell me that the actual exact match is kernel base create mutex w. So even if you're in some location that's not necessarily, so let's not say D0, let's say E0, it will tell you that you are now in create mutex w plus 10. So like I said, even if you get lost a bit, then the ln command is a nice one. It shows you the closest symbol to where you are currently in memory. Display header, it shows that when you know the base module of the file, usually it's loaded in 400,000 hex on 32-bit. You can just display all the header information. I'm not going to show that because it shows you the P header. It shows you all the segments of the file, all the sections and all the attributes of the sections and so on. It's very useful when you analyze malware, because malware often has attributes which are not common as normal files. Disassembling, I show you. UF is specifically made to disassemble functions. When you use UF, then you get the basic blocks, and every block, when you have a branch, it shows you the link to the next block. So you can click on the link and go to the next block. So it's useful when you know to disassemble functions. Now the controls. So these are those were the exploration commands. Here we're now going to control when you start actually debugging the code. So you can trace, which means you go step by step, or proceed, you step over a certain function call. Then you have some other ones which are very much connected to, like proceed until the first call. So here perhaps we can go just to see what happens when I run PC. So it just go, and then as soon as it hits the call function, then it will break. So very, very useful when you trace malware. You often look for the API calls, and then you're really not that much interested into what's happening before, because you know that sooner or later you get an API function call, and then you can look at all the arguments which are generally on the stack on 32-bit architectures, and PC and TC are quite useful in that sense. G is go. Go up is a go until return, but you have to be careful here because not all the functions end up with the return. So when you hit return instruction, only then you go up to the calling function. But of course you can return by push or jump, indirectly jump somewhere else. So some functions will never return. A couple of other commands allows you to set up when you're in a kernel mode. Then you can choose to which process context. Like when you're in user mode, then you debug a specific process. You have your main module, you have your own dynamic loading libraries, and you're always more or less in this virtual address space on that process. But in kernel mode, you really don't know where you're going to hit the breakpoint. And sometimes you're interested to be in the process context of a particular process. Let's say it's Microsoft Internet Explorer or Edge or some other browser or Explorer.exe. So using .process, you can set the process context and set the thread context using the .thread command. Breakpoints, also very important. When you have BA, it means breakpoint on access. So when you access the memory location where you want to read or write, you can set that up. So usually the write access is the one you're looking for. You have on the real 32-bit processor, you have four hardware-based debugging breakpoints. But if you have some new features that you can use in WinDbg, then you can have almost unlimited number of those BA breakpoints. BP is the standard breakpoint. But you can have some options like a breakpoint on certain address, and then after the address you can put a command which you want to be executed. So every time I hit create file, I want to read the first argument from the stack and display that first argument in my command prompt window. So it allows you to kind of almost like one-line script for this. BU is an interesting one, and it allows you to set a memory breakpoint on any symbol, even if the module that's supposed to be broken into is not yet loaded into memory. So you know that you want to load on some crypto function, but the crypto module is not yet loaded. You can still set up the unresolved breakpoint. So when the module loads, you can actually, in the best case, you will get this breakpoint. There are some other ways you can break for when any libraries are loaded. So there's some commands for managing the breakpoints, like breakpoint list, breakpoint clear, and you can also see BPC MDs, which kind of gives you a history of what you've done before to set up some breakpoints. So here we can see that I have two breakpoint commands, BP0 and BP1, and that's what I did in this environment. And the conditional breakpoints, which I kind of more or less mentioned, is that sometimes, like if you have a huge number of API calls for some functions, like messaging functions for the Windows, you have the messaging loop, and some function is called millions of times, but you only want to break when some certain condition is met. So you can have, like, if my window name is virus.exe, only then I want to break into this window messaging loop. It also allows you to, you can have like a script, and you can, this is like, I love this, how you know, whoever was developing WinDbg at the beginning, in third row here, you see this $, and then this kind of, I don't know, yes, so let's say smaller than sign. This is actually tells you call the script. So whoever was developing, it sounds like sometimes that WinDbg was developed only for the developer who developed it and not for other people, because it's. Yeah, I'll show you later some other ways of how you can call script, and it's really crazy. So these are the other ones, like exceptions, like SX. Is there like millions? There are a lot of exceptions within Windows which trigger on certain events. So you can set up your WinDbg or debugger to break on a certain event within the system. So for example, these are two examples. One, when the module loads, so when the new dynamic library loads, you hit the breakpoint, or when the new process is created. But there are a lot of different events. So if you only run SX, then you see that there are like about 50 different events, but like the first few are the most useful one, that, you know, create thread, create process, exit process, so you can break on certain things that typically you would expect from malware to do within your system. And of course, especially when you script, you want to have something that will output the results to your screen or to your window. Now you have two commands, printf and echo. Echo, I think, just gives you without possibility to format, to have a format string. Printf is like standard printf, where you can have different formatting strings to output different data. So here we see, like, especially one of the tasks when you debug malware is to often unpack the code, because malware can be obfuscated on the system, on the disk. So you wanna be able to decrypt it in memory to see this new module, maybe, or new code that's been now deobfuscated, and the way to write it to the disk, and so you can maybe load it in a disassembler, I don't know, like IDA Pro. Then you just write memory, tell it the file name, and then you give it the range, the start of the address, and the length of the range. So that's very simple. So in fact, like you see that you don't have to use all the menus. That once you learn, like, I don't know, 50 commands maybe, then you get quite a lot of power in controlling both the user mode and the kernel mode. A lot of these commands are equally valid in both modes. And now there's a little bit of complication, or again, it's due to I guess WinDbg developers, and the fact that Windows kernel is written in C++. So these guys, by default, you have so-called evaluators. One evaluator and default evaluator is the assembly evaluator, and here you see at masm. Microsoft Assembler. And then you also have a C++ evaluator, which is actually very useful when you know the members of certain structures. So you have a pointer, and then you can say an arrow, pointer to the structure, you cast the type, arrow, and then you can say, okay, this is now a C++ evaluator, instead of going through from one address to the other and then doing it in assembly. So scripting. Now we'll see that on an example of a script. For script, you also need some kind of language where you can actually control. You need to have some kind of looping and stuff, if then else, ternary operator when you say, well, if the condition is true, execute one thing. If not, then the other thing from that same command. You have the standard for each loop, do while loops, break, continue, and blocks, which basically just gives you like one piece of code. So here we see, I'm not going to go into in depth into all the scripting, but this is just an example to see. What this example is trying to do here, we see a C++ evaluator that casts a pointer to the list entry structure, and the PEB is process environment block, which shows the information about the process in user mode. Then we have a loader field. You see the arrow to the LDR, and then we see the arrow to the load order modules list. So we are setting the pointer to the lists of all the DLLs that exist in memory, and then we will traverse the forward. The linked list has a forward and backwards fields, which allows you to traverse the linked list in memory. And then basically you just do a for loop to the forward link, and eventually you print out the Unicode full DLL name. And here we again see we specify that we want to have a C++ evaluator where our pointer in temporary variable 2 points to the link structure that's cast, I guess, as a LDR data table entry. Yeah. And then full DLL name field gives you the name of the DLL. So it gives you some idea, and it's kind of error prone. You spend a lot of time putting together these, even for the simple functions. So and now my favorite bit is like, how do you call this? So these are all the ways how you can call a script in WinDbg. So these are all the operators. You give it the file name is the name of the script. And so you have this $, less than, bigger than. They all have subtle differences. The last one allows you to set arguments. The first two allows you to have, I think, semicolon as a name of the file. The next two don't allow you to have semicolon as a name of the file. So they kind of make it very simple. It's quite weird. Luckily, ta-dam, JavaScript, favorite language of everybody who develops any kind of application, full stack developers, so why not WinDbg? There are a lot of actually plugins that we are typically known that people who program in WinDbg generally use a Python extension for it called PyKD. But I have to say that looking at comparing PyKD and this JavaScript, which is actually done by Microsoft guys, I would say that JavaScript is more powerful, despite of my preference to Python as a programming language. So what it is they tried to build there were actually some improvements in latest version of WinDbg, and they built so-called debugger object model. So there are so many internal objects in memory of the debugger on the operating system, but also in the debugger's variables. So the Microsoft guys realized that it's very difficult to use WinDbg, and decided that they wanted to significantly improve the user experience and make the debugging much easier. So they built this debugger object model. We'll go through it a little bit in more details. But then they built a bridge between the debugger object model and the Chakra core engine, which is the Edge Explorer JavaScript engine that's also available as an open source from Microsoft, and then added some additional interesting things which are generally seen in C# and .NET programming. So how many C# .NET people here? Okay, quite a few, but I think we have a preference for open source Linuxy, Unixy stuff. Okay, so I just wanted to know. It also allows you to, the JavaScript doesn't allow you just to script, but also to extend the object model. So for example, if you need some additional field for like e-process structure, you're interested in some particular combination of two fields, you can create your own field, and suddenly that object and structure will have the additional field. It so allows you to extend that, and that's very powerful. So here are some of the objects or some of the objects in the object model you can have. The main one is the debugger, and the main command you use is dx. So the debugger represents the debugger itself, and then underneath you have like a hierarchy of various objects. And so we can see here, if I run dx and just see so you can also have different redirection levels. So for example, if I said dx minus R1 and debugger, it basically gives me this clickable, it's called debugging markup language, which gives you debugger and other members of the debugger object. So here we have sessions, settings, and if I go one level further, session is something that you created while you're debugging. Settings are the debugger settings. So if I go one level further, then I can see other possible commands. So we see that we have one session in a time travel mode. Anybody to guess for the time traveling mode? I would love to have that to travel back and past. But not only for a few seconds, I have to say. So here we have like state, you can see debugger variables. If you click on it, we have current session, current process. If you click through, so it basically allows you to see all the hierarchy of the object model, but also click through and investigate without actually knowing much about how you use the dx command, how you use. So makes it so much more user-friendly. If you know about the operating systems and the objects, then everything makes it much easier to use. So from then on, this object model, like I said, is not just visible through the debugger, but it's also visible in the JavaScript. And the new user interface, the WinDbg Next or the preview, also allows you to do something like within JavaScript set and execute commands like unassemble command. When you hit the breakpoint, you have host.namespace.debugger.utility.control.execute command. Super simple, right? Except you have in the right Microsoft way, you have all these kind of IntelliSense thing. When you press the dots, then if you know just a little bit, it kind of helps you with how you can get to your final command. But it's all well documented in a good old Microsoft ways, and so we can. I guess some of the commands are even clever, so they are not cryptic as the ones to load the script. We have script load to load the script, script run, script unload, list which scripts are loaded, and which scripts script providers are there. The first thing before you have to run any script, you have to load the actual extension that makes the bridge between JavaScript engine and the debugger. So load the JS provider.dll is the DLL name, and once when you have that, you are ready to normally run the script. And it also has few entry points within the script, like anything you put in the root of the script that will be run. Then you have special entry points like invoke the script, that's kind of like a main of the script, initialize script where it runs, but you're supposed to initialize some variables, and then that's kind of like a constructor, and then you uninitialize script, which is kind of like destructor, I guess. There are some minor problems. JavaScript only supports 53-bit integers, so in 64-bit mode you need to have a special object type. So that's very well known for Java stuff. So in this JavaScript there is the int64 object where you actually have some methods, like if you want to add two objects, then you go object.add and then add the other thing. You don't have a plus. If you do plus, then it warns you if you hit the overflow of 53-bit. So there are some minor issues. The other great thing they've done is they included in C# people who know more about C#. I have to say I'm not a great expert. There's so-called language integrated query. So it's an SQL-like extension to all the iterable collections. So you can basically have like something like some kind of iterable array, and from then you can have these. So we have a variable named current process, and then current process has all the modules. So those are all the DLL's module in the list. That will return the iterable object, and then from then on you go select, and then you have this lambda expression which says map m to m.name. M in this case will be a module. So you say I'm selecting name from the list of all the name field from all of the modules, and then I'm actually setting it as a where clause, similar like in SQL, where the name contains malicious DLL. I just put it as an example. So if I know the name of the DLL, I can iterate through all the processes, and I can iterate through all the modules very easily using the language integrated query, which basically allows me to then see if the DLL has been injected, in how many processes has been injected. So very, very useful stuff. The next command is kind of, I have you remember that script that was shown as that enumerates all the modules and displayed? I have the same script that I kind of put together today in the morning, yeah, as you do at the conferences. Just in time, exactly. So, but it's super easy. I mean, it's super simple as well. So nothing very serious. So scripting, I can just go open script. There's a scripting tab. My favorite name, script 1. So I load the script, and here you see that the entry point is invoke script. And then I just go, like, my modules are host.currentProcess.modules, and then I just have a standard for loop. 4 modules in array modules, and I go basically host.diagnostic.debuglog is print or equivalent to print, and I give it the name. So really, three lines of code. When I execute, I will get more or less the same thing. I'll get all the modules that are loaded. And it's so much easier to work with comparing with the standard, or what they call it, Descript, I think, in WinDbg. So this is like, for you maybe it looks simple, but for me it's kind of revolutionary. It's so exciting. And then the next thing I want to really do is dig much deeper in this JavaScript functionality, because it really is powerful. Time travel debugging, yes, they have that. Not many debuggers, as far as I know, have it. Microsoft had it for a long time. They used it when some application would crash. They would send a utility which will allow any user to record the trace an application from the moment it started to the moment it crashed. So imagine how, for vulnerability researchers, how many vulnerability researchers here? Bug finders, whatever you're going to call it. So essentially, when you hit some kind of error condition, you record the trace, and now WinDbg allows you, if you're on Windows, to load the trace and to appear as if you're really debugging on a real process. So instead of just running forwards, you can also run backwards. So I set up a breakpoint. So you can set up backward breakpoint. So when you have a breakpoint, and let's close this window. So I have this breakpoint on heap create function. I just randomly chose. So instead of if I go forward, I will go GC is like go to the next call. Why? Okay, never mind. Let's try something else. Okay, breakpoint list. We have list on kernel base heap create. Okay, so if I go but with a minus, then I kind of go backward in time, and so I can go backward and I hit the heap create point. Breakpoint, but then I go GC, I go forward, and I hit the next call, which is the call we've seen before. Okay, it's which? Okay, let's go once again. Okay, I hit an exception. Okay, never mind. But you get the idea. With the caveat is that you need to be aware that the traces obviously put a big files on the disk. So those are like, they record all the memory locations that are used, and they can be hundreds of gigabytes long. So it's not like you're going to transfer it from the client's location to yourself easily. But when you do the debugging, it's very easy to just like go back and then come back to where you came from by simply loading this trace in, recent things, start debugging. You already have it set up. Okay. Yeah, that's how it looks like. So you have two. If you're a Microsoft guy, then you have these buttons. So play button, go, and then you have a blue play button, go back. So you can go step forward, step back, step forward, step back. So you can basically play with two until you achieve the condition, error condition, or you see what malware did just before it got lost somewhere. You don't have no idea what happened next. Okay, so how are we doing with time? Oh, we have 10 minutes. 10 minutes, okay. Some just other side things you need to really know especially when you do your kernel. Everybody's more or less aware this is Microsoft standard. I took it from a Microsoft website. It was done in 2006. So Windows 10 is possibly nothing like this, but from the point of view of the malware researcher, it's still very much the divide between the user mode on top and kernel mode, which is also like I said, supervisory mode, where everything is accessible once you're there, and then you have this boundary that you cross using a system call or some kind of call gate. There are few Intel instructions that allow you to do that if you're on Windows 64 running Windows 32-bit code. Then you have another call that kind of goes from 32-bit mode to 64-bit mode kernel like a gate. But generally it's like that. When you're doing a user mode analysis, you have your application, and then you have your Windows dynamic loading libraries. Kernel 32 is the most popular one because it has most of the functionality in Windows. And then on the kernel side, you have so many different things, but the important things are like the memory manager, object manager, management of processes and threads, various different drivers like TCP/IP driver, generally everything that malware may need to use as a kernel mode module, and it may kind of change it in memory. Here are just some of the structures that I already mentioned before that you kind of need to know. Unfortunately, some of the kind of mechanisms around it is not super simple, but when you do it, the kernel mode analysis, you need to know, kind of be aware at least of most of it. So here are some of the commands. I won't go through all of them. Mostly kernel mode commands that allows you to look at all the drivers that are loaded, that allows you to look at the types of objects in the object manager of the type driver, that allows you to enumerate handles which are connected with particular process or particular object. And why is it important to know more than one of these commands is because that some of those commands will lie to you when you're in kernel mode and analyzing, let's say, a kernel rootkit, because the kernel rootkit will try to remove itself from the list of modules, remove itself from the list of remove malicious user mode side from the list of processes and so on. So you need to know several different ways of how to approach the same thing. So you try to run it, and it's almost like a differential analysis where you get one result from one command, you get a different result on a different command, and go, ha ha, I got you. That's not always possible. Sometimes you spend a lot of time crying as well. Some of the other commands for analyzing like processes, they're like when the commands are starting with exclamation point, they will say, they're not commands, they're extensions, because that's very different. Extensions can be part of one dynamic loading library, or can be part of more than one extension can be part of one DLL also, but generally you have extensions that are in a single DLL. So you have an extension for Python kernel debugger. You have some other extensions which are quite popular for, let's say, finding kernel mode malware as well. So in order to analyze kernel mode malware, you need to be able to load it somehow. So you can set it everything yourself manually in the registry. Generally, you need to set some registry keys. You have to create a service that will run in the background, and then you have a call to load the driver in memory. So before that, you need to disable all the integrity checking by the operating system, because if you don't do that, the malicious module of the driver typically won't load. But here are two utilities, one from the OSR free utility and the other one from No Virus Thanks, that allows you to, they set up most of the parameters for you, so you can simply load the driver. And then you can set the breakpoint when the module loads, and as soon as the module loads, then you can hit the breakpoint and you continue with the analysis. So what would you expect from malware? Usually that tries to do some hooking, either the API functions in the kernel itself, which is more rare these days because you have patch guard and protection in the kernel, which becomes better with every version of the Windows. So it's non-trivial to do it. However, there are a lot of documented calls now, because you have to be aware that functionality of a lot of malware is actually very similar to functionality of, let's say, anti-malware software. Anti-malware software is also interested to have a higher privileges than the standard user code, and it also tries to kind of intercept the communication between the user mode processes and the kernel. So it inspects the behavior. So Microsoft guys for a long time refused to create any kind of documented interfaces for security code, but then they had eventually succumbed to anti-malware companies pestering them, because there would be so many blue screens of death otherwise. And so now there is a number of documented APIs which you can use. Malware is also prone to use legacy drivers, so you have some kind of old drivers with a valid certificate that you can load in memory even if all the checks are in place. In that case, if there is a vulnerability, you can exploit the driver in memory, and then to exploit the driver, that would allow you to write wherever you want within the kernel space, which basically disables the integrity check in kernel space. So you write something through the driver that's some kind of old driver, you exploit it, you disable the integrity checks, and then you're free to load your own driver. That's what some of the malware stuff. That's the kind of a typical thing. Turlai, I think, is the rootkit that's known to do this. Here, these are the list of those documented system calls. We won't go through them. Some of them allows you to set a callback when the registry key changes, some of them when the process starts, some of them when the thread is created, some of them when the module is loaded. But these are the good pointers if you ever analyze kernel mode malware, where you can set the breakpoint. For example, most of the drivers will create, before they start, the driver entry point is called driver entry, and then you will have the IO create device code. So very soon after the driver entry. So if you have an obfuscated driver that is packed, and you don't see this IO create device, perhaps you can set the breakpoint there, and so hopefully when the driver is decrypted and deobfuscated in memory, you will hit the right breakpoint and you can continue with your debugging. So here are things that you can do. You have to enumerate the drivers. Like I said, you need to have several different ways of scanning the memory or looking at the objects. So because you will have disparate results from different ways, and that's how you discover some of the malware. Here I also put few extensions that I also used, like Swish debugging extension by Matt Swish. Really cool, because it allows you just like a single command that basically scans all the callbacks, all the documented parts of the memory, so it displays to which modules do they point. So hopefully you will be able to catch the malware by using that. WinDbg ARC stands for anti-rootkit. It's some, I think it's a Russian developer from Kaspersky. They're all very useful, so anything that helps you to find malware. But like I said, you have to be very careful. And here's an example. You have driver object structures, and you also have this loader data table entry, which I'm sorry, you don't see that well, but basically there are two objects and they have the name of the driver here in red. And malware in this case zeroes out both the full DLL name and the driver name. So basically when you zero it out, when you do the scanning with any of those extensions won't necessarily give you great results. So here we see a list of modules that are registered to be notified when the new process is created, and we see like Windows Defender, integrity checker, and then finally the last one in red, it doesn't give you the module name. So you just see that something is registered, but you don't know where the module is. You know, you'll catch the procedure, you will find it in the end, but it's kind of weird because there's no module name. Okay. I think with that we can actually finish. I have a few more slides, perhaps, I don't know. Anyway, two of the kind of somewhat unusual use cases. One which is done for unpacking managed code, so the C#.NET code. Typically malware comes in some kind of packing, packed or encrypted, where you have the module that makes it more difficult to analyze. Even if here's a disassembly, and it's typically you see that there's some kind of decryption happening, but you don't know it because you don't have it in a debugger. So what the WinDbg allows you to do is to set up a managed breakpoint as well on the manage functions. So you know that malware, when it wants to load an additional module, calls this system.reflection.assembly.load. You set the breakpoint, but because it's a .NET or managed code, there's more than one function, like with overloaded parameters. So it sets up about 7 different breakpoints, and when you eventually hit that breakpoint, then you can look at the stack pointer, and when of the Assembly.Load function, and the stack pointer gives you the parameter. So this is 32-bit. The stack pointer points to an array, and that array consists of the length, which is in this case 5e00, and here you also see this 00905884D, which when you look at in the memory as a byte by byte, then you notice the MZ, which is like a dead giveaway that something is an executable module. So here we run something until the new assembly is loaded. We were not at all interested in any other functionality until we really wanted to find the actual module. So now when you have the module, we simply write it into a file, and we can load it normally in a decompiler and decompile it as such. So this is the second similar thing. You can also debug JavaScript, or JScript rather, so you can that's interpreted by the Windows scripting environment. So here we have like a simple script, and with 2 eval cases. So one which kind of evals some command that we run, in this case Notepad, and in the other case we have some kind of mildly obfuscated base64 obfuscated string. So we can actually set up when the JavaScript interpreter is loaded, we set up an exception. So once it's loaded, we set up a breakpoint on JScript eval, JS-eval, and then we saw how the JS-eval looked like, and we actually see that there is a JScript all script compile, which gets the actual JavaScript code for compilation. So we want to set the breakpoint on that, and once when we hit the breakpoint, we can look at the parameter of the call. So here we have an example of a breakpoint that actually runs a command after it. So when you hit the JavaScript compile, then in the register, temporary register 1, we put the pointer to the second parameter and pointer to the first parameter, and then you basically continue, you display that parameter and run later. So we run the whole code, and we hit the 2 breakpoints, and both breakpoints come up with the actual code that's supposed to be eval. So first one is calc, the second one is Notepad. So that's as simple as that. So with that, those are the 2 less commonly used WinDbg use cases. I think we can all relax and breathe. The conference is finished. We can have pictures of dogs and cats. These are mine, but I'm sure all you have yours. Yeah, I don't know if we have any time for questions. Hopefully not. Yeah, any questions? Hetty will ask the difficult question. No.
So, but when the malware runs in kernel mode, they can just see, okay, you just start debugging, and they just like it's like kill it. Should be possible.
Yeah, I guess they can. It depends. Like if there's a kernel thread, which you can probably enumerate. Like malware needs to run somehow. So you kind of load the debugger from the outside. As far as I know, I haven't seen malware that looks to see if there is under the kernel mode debugging. And under the user mode debugging, yes, there are like hundreds of anti-debugging techniques, which again there are extensions which allow you to try to circumvent. With kernel mode, I haven't seen that much. I think I've seen more problems in being like very packed and obfuscated, so it takes like horrible amount of time, and as soon as you load, you go, I don't want to do this. I don't want to. So it's more. That's kind of how they do it. More in my opinion. Like you have VM protect for kernel mode, and that's like. Bleh.
Thanks.
No more questions? If there are no more questions, I can invite Jelena to give us the final spiel, and thank you for listening to what I had to say. Thank you.